Welcome to the third day, everybody. You're in track 15A, and it's my privilege to introduce one of the most famous, and I'm going to say infamous too, if you're okay with that, Usama, CDOs that we have had in this short career field. If I were to read you his bio, it would take the entire hour and you guys would all be very upset with me. I will just briefly note, though, that this is an individual who has not one but two PhDs, has received more than 30 patents, was instrumental in setting up some of the groundbreaking work that we've done in the area of CDOs, and has been so kind to share his insights with us continually over the years. Most importantly, though, he has just started up a brand new program at Northeastern University where we have lots and lots and lots of colleagues in the data world here. So we're looking at Northeastern to become a very large powerhouse of the data world coming out of this. And his talk today is digital without data. And we are certainly looking forward to it. By the way, he also says leads to blindness. So we can sort of tease that one out a bit. Usama Fayyad, it's such a pleasure to have you here. Thank you. And I will shut up at this point and look forward to your talk.
Oh, thank you so much for that kind introduction. Let me try to get my timer here in place. These things never work. Fine. Thank you for joining us today, and hopefully I'm going to try to cover an ambitious agenda here, where I'm going to challenge some of the myths and beliefs out there, relating both to data and data and AI in particular, and data in the age of digital, which we've all kind of experienced recently, and understand how much digitization has been driving the world. So let me start with a basic theme, right? Making AI work correctly is one of the grand challenges facing us today, in my opinion. Everybody wants to do AI, everybody needs it. And it is accepted that digitization has taken hold and has been accelerated dramatically through our experience with the COVID pandemic. AI has been a great and difficult challenge over the years. We've been at it for 80 years with, in my opinion, little progress to show on algorithms. And we'll talk about that. Machine learning has been the dominant part of any working AI. And that's primarily not because we have better algorithms in machine learning. We just have more data. So machine learning, first of all, has a huge dependency on data. That's an obvious one. I don't think I need to defend that. Despite data being so essential, most organizations to this day are struggling with the basics of data and making data work as an enterprise asset. In fact, I'll argue it's a liability in most cases. The myths of data in the enterprise is what we will tackle. And where does the human fit in with this AI story that I just kind of said in a short format, and I'll elaborate on during this talk. Feel free to post your questions. We'll leave time at the end to answer as many as possible, and I'll answer many others online if you have more. So, myths of data in the enterprise revolve around getting to the right data assets, utilizing the data assets, and protecting those data assets. And I'll talk about those three aspects in this talk. You talk to people and they say, well, we've been dealing with data at rest and data in motion, and now we're kind of figuring out how to utilize data, not just for analytics, which is a completely different usage of data in terms of granularity, et cetera, but also to drive AI. And people will say, hey, check mark, we got that one, right? We've got encryption, we've got physical controls, check on that one. We've got data in motion under control, you know, SFTP, HTTPS, and all sorts of other protocols. Data in use is a big question mark. Now, the theme of my talk is actually we have big question marks on all three. And I'm going to address in particular the data at rest and data in use stories as myths to be kind of addressed. And I'll start, of course, with data use in AI. So data in the digital and AI age, my first question is this an asset or a liability? Are there economical and practical approaches to utilizing this data? How do we utilize those data assets once we have assets? And that's a big question. And finally, protecting the data assets. And at the end of the talk, I'll talk a little bit about what we're doing at Northeastern in terms of the Institute for Experiential AI, and give you a quick kind of taste for how we're approaching this. Digital transformation. I'm going to use financial services as an example because they're often used as kind of the leaders in kind of digitization and utilizing data and all that. Again, very big myths. But financial services has been undergoing major digital transformation for the last 7 decades. This is nothing new, right? Fintech is the latest you hear about, and AI has gotten a lot of attention in this recent fintech efforts. A simple dramatic example is accounting, right? If you go back 60, 70 years, to be an accountant, you had to have a good handwriting, good addition skills in your head, and you had to be able to kind of manipulate. And some accountants told me, avoid getting killed by these big ledgers that may have fallen on them. In fact, the CEO of Logitech used that in one of my podcasts and said, you know, he almost got killed with one of these big ledgers in his early career. If you look at accounting of 60 years ago versus accounting today, completely different, right? And if you hear a lot of the noise about AI and replacing jobs and all the tech, reality is we have a lot more accountants today than we ever had before. They do a lot more higher level things that are directly useful to the organization than they ever did before. So that's an example where a whole field got changed completely in terms of how you think about it, how you use it, and how essential it is to the business, while creating many more jobs and higher value jobs in general, right? So that's our extreme example here. So what happened with the novel coronavirus pandemic? Well, everything went digital, right? We can't go to the store. We got to do it at home. You know the story. Everyone was forced into digitization. And basically the dynamic was all the naysayers, all the risk-averse folks no longer had a choice. They either had to jump off the cliff and do a leap of faith, or stay where they are and basically become walking dead. And in fact, those who jumped and those who look, they saw examples of saying, hey, this is not so risky after all. We can adopt technology, it works. And that got us to a wide adoption of digital, and a lot of people focused on digitizing workflows out of necessity. But something else happened here. So before I go into that, let me just give you examples. I mean, historically, people who failed to embrace digitization, Kodak is a perfect example. They went bankrupt after 124 years being a huge, effectively brand and landmark in our lives. JCPenney more recently, after 118 years, like think of what they survived, right? Including the first pandemic. They actually could not survive the failure to digitize fast enough. And of course, we've got new, I use examples from insurance and banking here, but companies who embrace digitization are kind of emerging as new winners, right? So you've got Discovery with their Vitality program, which kind of utilizes step counters and other things to kind of help you maintain a healthy lifestyle and at the same time reduce your risk of insurance. Capital One in the US is a great example of embracing data and digitization for marketing purposes. DBS was a bank in Singapore that almost went bankrupt, went through a huge transformation. And if you talk to their CEO, they'll tell you that primarily it was digitization and data that kind of saved them. And now they are the leading bank in Singapore. But what has been lost in this, and this is not caught, and this is where blindness comes in, despite the fact that manual operations are expensive, they're slow, they're inconsistent, they gave you feedback, right? As an organization, you understood why is a customer leaving me? Why is somebody happy or unhappy? What can I do better to keep them? All that intelligence was indirectly and manually coming back to the business and helping, of course, decide strategy and helping respond to the market. So we lost that customer intimacy. And that, of course, the hope is that data, especially through big data and capturing all these new metrics we have, can we substitute kind of that sense of understanding what the customer is up to? Can it serve as our eyes and ears, if you will, and avoid taking us blind? But I will tell you today, the typical digital transformation, maniacal focus on digitizing workflows, completely forgetting about data, completely catching themselves after the fact saying, well, I'm now digitized, congratulations, but I don't understand what the heck is going on. So with that, the key theme here is data is the key, right? to kind of restoring that. And this works both, I'm not going to spend time on an example here, but it works both for the front office, which in the old days was very intimate, very manual, very based on relationships and knowledge of people, and the back office. Evaluating, assessing risk on a loan in the old days was very easy. You knew the person. You knew whether they were going through a good business cycle or a bad one, divorce, sending a kid to college, needing to buy more equipment or a horse or whatever. Nowadays, as banks went digital, they literally completely went blind. They no longer understand what a particular customer needs. A quick example of this, Kelly is a customer, deposits money into her account, is good standing with the bank, end of story. Well, it's not the end of the story. Had the bank synthesized this data and understood what Kelly is up to, they would have known, and they actually have this data and they know it. Kelly has a student debt. Kelly has just gotten married. What could they have inferred? Well, Kelly is saving to buy a house. The bank can offer Kelly refinancing on her student loan to help save. The bank can offer a loan towards the house, etc., or helping her save towards the house. Those are examples of intelligence action that could have happened. The data is there, yet in almost any bank you walk in today, they cannot get to that data. They cannot get to that level of knowledge. We'll come back to that point a bit later. So the question is, in this age where we've digitized, we've had 100 times more data flowing through because of digitization, how do we avoid getting overwhelmed? How do you utilize this data? And more importantly, how do we leverage the majority of this data? 90% of it is unstructured. And about 100% of databases speak structured only. And most technologies that's in use and talent that's in organizations know only how to deal with structured data. So we're kind of handicapped in a huge way, not knowing how to leverage 90% of that asset. Now, AI, I talked last year about my brief history of AI and all that, so I'm not going to walk you through that this year. AI went through a couple of winters, mid-70s and early 90s. And after those winters, you go from like exuberance, where people are proud to be AI, to people saying, I had nothing to do with AI, right? I never worked on AI. And I know that because when I graduated with my PhD in the early 90s, I was like, the world was in denial. Like, if you did AI, you're a bad person. And by the way, its definition is very simple. It's kind of simulating human intelligence with computers. The problem is we don't know how to define intelligence. We don't know how to even address common sense reasoning. Machine learning is a subset of that field, having to do with kind of changing behavior based on observed data. That's all I'm going to say about it here. I'll say that the hype continues, right? Today you hear about kind of how we're all going to be jobless, brainless, and China 2030 is the new. Back in the 90s, it was the Japanese fifth generation systems that were the big threat. Nothing came out of that. I think there's a much more serious situation now facing kind of China's progress, and we'll talk about why China has succeeded so well in that. So that's that hype still continues, and that's going to lead us, my prediction, into the next AI winter. And that, to me, that's coming within the next 5 years or less. We will go through a winter of disillusionment. The good news, though, is machine learning has survived both prior winters and will likely survive the third winter, not because we have better algorithm, not because there's been advances in understanding the learning mechanisms, but it's because we have a heck of a lot more data. So that data enabled us to do a lot more. By the way, it's not easy. According to Gartner, 85% of big data projects fail. And like I said, 90% of data in an organization is unstructured, and most organizations cannot deal with unstructured. So we're still in an age where we can't benefit from all of this. Last year, I shared with you my 5 lessons learned from the front lines in terms of doing AI and what makes it work. I'll just summarize them here, but I want to focus on the last one, number 5. So you got to go very, very, very narrow to have a successful AI application, where essentially the data gives you complete information. The data is a necessity, and it's necessary at a very granular level. That's lesson number 3, which is very different than what you need for analytics for humans. You need to kind of go beyond just raw data and understand intent. And there's ways to systematically do that. We have something called the intent architecture. And the most important one is there is no autonomous AI, there is no general AI. AI is about a human-centered AI. Systems that help humans perform a task they consider intelligent much better by augmenting or amplifying abilities. We'll come back to that lesson number 5 throughout this talk. So we started with the myths of the data enterprise around getting the right assets, utilizing the data assets, and protecting the data assets. And we talked about the at rest and in motion and utilization. Let's talk about utilization. You go to a typical company and you ask, what do you expect from your data? You ask the business users and say, well, I want data to be reliable, affordable, timely, accurate, comprehensive, unified, accessible, easy to understand, easy to embed into business actions. Reality is none of these hold, right? It's unreliable, fragmented, expensive, difficult to get to, batch, slow, confusing, questionable quality, unusable, etc. And through many, many years, I've been at it for a good 30 years now, trying to make these data systems work and deliver the data assets. I've converged on kind of, big data does offer us a big solution here because it can accept both unstructured and structured data. And it's a question of how do you run it as an ability. This is an example I use a lot with data fusion, where we built it for cybersecurity first, then immediately in a bank, and immediately financial crime and fraud groups came to us and said, we need exactly that data that cybersecurity is using. And suddenly, and they had their own databases, right? But this is the only place where we captured everything and put it together. Then, of course, marketing, risk, many other functions in the bank came and wanted it. We have been doing data strategy with a lot of organizations, sometimes as their chief data officer, sometimes from the outside, helping them through open insights. And we have 5 hours of data strategy, right? Which is, what's your revenue opportunity? How much, what's the catalog of opportunities for data? How does it relate to the business goals? Relevance, which is how do you make the products more relevant to your customers? Reference, do you build to a reference architecture? So as you're building each use case and delivering value, you're building to a standard. Regulation, which includes data governance, standardization, etc. And the roadmap. How do you get from here to there in steps, in slices, never trying to do boil the ocean, because that never works. So the big question I always ask, is data under control and is it driving business growth? That's my litmus test for an organization that's kind of utilizing data. And sadly, for many organizations, this is not the case, let alone getting to the point where they could utilize AI to drive data. The solution that I found consistently is the only way to make things work is what we call data as a service. Build the data systems as a utility. So nobody builds their own databases. You're building it in one centralized, standardized place. And you have specialized team who do only data. I often use when I was in Barclays, the global chief data officer, I utilized the London Underground example, right? You don't drive the train, you don't decide how much the driver gets paid or how fast the train goes or where the stations are, but there's a very defined, standardized interface for using that utility, right? And it's not complicated. You could find your way around it quickly, etc. So that data as a service is a key to make it going, and we've learned a lot of hard lessons by doing this. These systems don't have to break the budget. Never do them as a boil the ocean, let's fix our data problem. Always do them in the context of use case by use case, but do them to a standardized architecture. Know where you're heading, and every pilot you build or every use case you solve needs to fit in very nicely. We call it the Lego blocks architecture. Garbage in, garbage out, which means data governance, mostly by technology, not by people, not by committees, is essential. Don't go with structured data only. That limits you to only 10% of the value. You can benefit from that unstructured data, especially for data science and AI. And then trying to do kind of these long-term migration projects is a recipe for failure. You got to have a blueprint and you got to deliver on it incrementally. One new valuable use case at a time, keeping the business always engaged with the progress on the systems and the technology. And of course, lack of talent is typically the biggest problem, right? Even if you build the best systems in the world, if you don't have the talent in-house that understands it and can operate it for you, it will quickly deteriorate into a non-asset again, right? Into a liability, waiting to be externally hacked or internally leaked. I'm a big proponent of kind of having the unified customer view, like your data from I'm using customers as an example here. It could be products. is all over the place in different areas. If you bring it together and maintain kind of a view of it, we call it the unified customer view. You can actually have an easy to discover, easy to utilize, fast way of kind of getting to what you know about a customer at any one time, which changes the way you acquire customers, communicate with customers, how you position to a customer, right? Are they interested in a loan? Are they more interested in making money? How do I price to them strategically? How do I get a competitive edge over others by appearing and being a lot more relevant, right? All of that has to do with knowing that customer and leveraging what you know about them to deliver on that. I like visualizing that through this view. This is a view for a telco as an example. If you ask, for example, a customer of a telco, how do you view the telco you're working with? Well, they'll tell you, I use some of these utilities they have. I use voice over IP. I do phone calls. Very transactional view. If you ask the telco, what's your view of the customer? They'll say, oh, they have this good connection this often, bad connection that often. They've done some transactions on their wallet. They do this much voice, this much, on the financial services side of it. Very transactional view. In reality, that telco actually has amazing information about that customer, right? And they have permission to know this, right? You can tell as a telco when somebody is trying to buy a house, when somebody is trying to get married, when somebody is, or getting married, buying a car, getting a degree, having a child. You think these are hard to infer. They're not actually. But also day-to-day events. I'm trying to commute. I'm paying my utility bills. I'm trying to entertain myself. I'm shopping. I'm traveling. Well, now that travel is back. All of these things are available to a telco, but a typical telco doesn't have that view, doesn't understand this about this customer. This one is likely to travel more. This one likes to go to these kinds of destinations, like sports, etc. All sorts of relevant things that can then be used to understand and position and retain and grow the customer relationships. So back to the myths of the enterprise data. So getting to the right data assets, which I just finished saying is a challenge, but is doable, especially if you follow that formulaic data strategy and data as a service approach to it. And I'm happy to answer questions on that. The second one is in utilizing the data. And the third one is on protecting that data. So as we said, people think these problems are solved. They're not. Let's talk first about use, where they'll admittedly say, we don't really know how to use data, right? So how do you use that data? Let's say you have the data for now. Ignore the fact that it's difficult to build that asset. Let's say you have an asset. Now you have the next question, which is a good question to have. Do I use it, right? And you can go from an extreme of saying don't use or even collect it because it's just a liability. I can control access, like, and restrict it to a few key people who are anointed by some special oil to have access. I can do encryption to kind of get sophisticated around protecting leakages and all that kind of stuff. I can tokenize and mask the data. I can anonymize and aggregate, which are favorite ways of doing this. Now, the first argument I'll make is this is what should I say? This anonymization can be literally a joke from the point of view of algorithms, right? There is no anonymization or tokenization that works well, right? And often when you tokenize, either you take it to an extreme where you lose a lot of information, or to an algorithm, it looks something like this. I've just anonymized this picture, right? The face is not there. You can't possibly recognize who this is, right? Come on. Like, look around, look at the surround, and you immediately know who this is, right? So again, this is what it looks like to an algorithm, a lot of the anonymization and kind of de-identification algorithms. You can also, by the way, attack a lot of these things, even the mighty Google, right? So here's an example I like to use. I got it from a company I advise, Leap Year, who does a lot of interesting things on differential privacy. Google Translate. Here's an example of an attack, right? Somebody wants to translate from Maori to English, and the attacker just types dog, 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 dog. The algorithm gets completely confused. Why? Again, this is the brittleness of machine learning. It has never seen anybody doing this kind of query. What does it spew out? It spews out stuff that's coming from the training data that was used to train the language models, right? So it's kind of spitting out something about the doomsday clock and the end of the world and all of that kind of stuff, which has nothing to do with dog, 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 dog. It just shows you how brittle these things are and how easy it is to expose information that shouldn't be exposed, right? This is an example of an attack to try to figure out, well, What did Google use to build this model, for example? Very old idea, from 1965, is don't give responses, but give randomized responses. And that actually is one of the guaranteed ways to create differential privacy. I'm not going to go into how this works or the math behind it, but basically trust that there are theorems and provable ways of saying, here's how we guarantee you that privacy is preserved and you can never resolve to what data about a particular individual is, right? The example of that is, let's say I want to do a count, right? I do the query, and it goes through to the data and touches the sensitive data and comes back with an answer and says your count is 200. If you were doing a differential privacy thing, you might get an answer that says actually 202 plus or minus 2. Actually, it should be 200 plus or minus 2. Or actually 201 plus or minus 2. I apologize, there's an error here. But the whole point here is you don't get an exact answer, but that answer is extremely informative from an analytics and from a modeling and from a prediction perspective, right? So an example here, without kind of de-identifying this data, without putting it through, you can easily break a lot of the masking, right? If I give you only a location data that's anonymized completely, right, where you can't tell where my location is, if I go to that location on 4 separate times, there's a 90% chance you'll figure out who I am individually. If I go to that location and I give you 4 times and I give you the amount spent, 99% of the time I could guess who that individual is, right? And the extreme example, there's a reference there to this example, but an extreme example here is I have an average salary of a population, including this person, Maya. It's 50K on average. Once Maya resigns, right, the average goes to 51K. I can easily re-impute her salary and know that exactly she was making 38K, as an example, right, below average. Here's an example of a 3-digit zip code kind of anonymization. You lose a lot of information around this. This is healthcare data and healthcare effectiveness. If you go to 5-digit, this is what you see. The question now is, can you go to 5-digit and preserve? And the answer is yes, if you leverage something like leap year and differential privacy. Here's powerful examples of what you see, right? This is anonymized at zip +3. This is anonymized at zip 5, the full zip, but utilizing differential privacy, which guarantees you the privacy. Here's something now, the result here, if you look at distributions, this looks like unimodal, right? You have one mean, etc. Reality is it's bimodal. And you get that, of course, from the higher resolution, but randomized data. You get that, the bimodal here, the bimodal here versus here. So this is how powerful it is to be able to share that data at a detailed level, but be able to anonymize it on the individual level. And by the way, proof of the pudding is if you look at predictive models, right? So you say, hey, this is my model on anonymized reduced data, and this is the unreduced but protected data with differential privacy. And you get a very significant lift here from a prediction perspective. A lift in the ROC curve means your predictive power is much better. Your recall versus accuracy, you're operating at a much better point anywhere on the curve. And that's very important. So it works for understanding from a visual perspective. It works for algorithms that need the detailed data. And remember, these algorithms are not accessing the detailed data. They're accessing the differentially protected private data, which is detailed. This changes how you utilize data, right? Because if there was some value, a total addressable market for data, if you have to do things like anonymize it because of regulation, geographic restrictions, client expectations, public perception, you go down in value dramatically, right? And that limits the ability to kind of monetize the data. I'll use a few examples here to kind of convince you that this is the case. You can try to protect data where it's stored, right? In the data layer, we call it. And that is a lot less effective because then you have to worry about how will somebody use it? How will they attack it? What are the results? The other approach is to say, I don't make any assumptions ahead of time. I protect it at time of use. So instead of using the data directly, you go through this differential privacy layer. This is the leap year approach. you go through that differential privacy layer, and you have the system decide at the time, because it now knows who's asking what question, which data sets, and who is the user. Based on that, you can then kind of expand that awareness horizon. You can expand what you can share with them without putting anybody at risk, because you're not giving them data, you're giving them results, right? And that could be, the user could be an algorithm, it could be a human. So that changes the game. Final comment on this one. The typical approach here is when you do a lot of encryption and you try to predict at the data layer, you have to actually punch a hole through that, and somebody needs to have access to it. I often, and this is usually viewed as an external party having access, but they punch through all that protection to give access to that person. Well, that opens up the whole window for people to come in and do bad stuff. And you have to address issues ahead of time, data commercialization, cross-border, cross lines of business, third-party data sharing, etc. And that's why protecting it at time of use is probably the most efficient way to protect it. By the way, under GDPR and CCPA, there have been legal opinions, right, that actually say, differential privacy is acceptable under GDPR and under CCPA, and protects and meets the compliance requirements there. So it's something to pay attention to, and that kind of ends my coverage of the leap year stuff. But wanted to share with you some examples of how you get value from doing this anonymized sharing of the data through differential privacy. One in capital markets, which basically has to do with prime brokers who basically get orders from big trade funds, but they have to share back data and say to the market, here's how many people bought this and bought that and bought that stock. But if you do that, you risk revealing that particular hedge fund's strategy for sharing, right? But if you apply differential privacy, you can actually share while saving money. And in this case, it was significant. It's $10 million in additional profit from the same data, just by applying that one layer that says now you can share safely, and you will not disclose any of the strategies of any of the big traders in your pool. And that's a big deal. And credit card network is another example, where you get merchant transactions, put them together with bank transactions, and kind of get to kind of what products are being bought. There are many rules that apply here, but the whole idea is to basically allow the view create new revenue without ever disclosing who, details that can help you infer who the consumer is. And by the way, there's many rules here. There's a 525 that says, for example, says it cannot be less than 5 people in any view of the data, because anything less will reveal information about a private individual, and it can't be concentrated more than 25%. So no one individual entity can have more than 25% share of that view, right? So those are like rules of thumbs that get used, and differential privacy obeys a lot of these. Last example here is on data monetization. Again, 75 million of incremental revenue, sharing data about utilization of health services to hedge funds and other traders to kind of help them understand without giving up anything. This is done with a top 10 bank. And to give you an example, the trade financing solution as an example, for example, they were running, this is the first one I talked about, they were running with a 20 to 30 million profits, because they could only publish restricted lists, right, for fear of divulging what the strategy of a certain trading firm might be. But with differential privacy built in, you never see the actual data, but you see the outcomes. They can now publish a lot more, 80 billion worth, which increases their profits by 30 to 80 million. So these are real recent data. We talked about now data in use as being kind of questionable, and to me, differential privacy is one of the most promising ways to think about it, including, in my opinion, restricting your own employees to never use the actual data unless there's an actual need, like a customer service on a particular individual. Everybody else should have differentially private views. Let's talk about data at rest, right? And I'll end with that. The theme here is data at rest is secure. Well, here's the example, the famous one, infamous one from Facebook, right? 2018, 87 million members notified they were hacked. By June, and these things always, it's the tip of the iceberg. It was a lot worse, right? 120 million. By October, it basically got classified as, you know, the next wave of that same attack was, biggest hack in history. Even Mark Zuckerberg's and his COO's accounts got hacked, etc. Right? So these things are always very, very dangerous. That data that you think is safe, that you spend so much time protecting, and we're seeing it today. Probably ransomware is now top of mind of everybody, but I assure you, there is a slew of different attacks, right? Ransomware is just the most recent attention grabber. Critical infrastructure, we've seen a lot of those attacks, countless companies, by the way, affected. Many never reported. They just don't want to tell anybody about it. They'd rather pay the ransom and just go on with their business, which is a cheaper economical solution. Manufacturers, we've seen even recently a meat processing plant. Like, who thought a meat processing plant would be the victim of a cyber security attack with ransomware? The pattern typically is you gain access as a bad actor, you take over an application and change it a little bit. From it, you spawn up a new process. That process now is home free. It can do whatever it wants. Typically, it establishes a connection back if it can. If it can't, there's another technique for dealing with it locally. And it encrypts everything using these keys that are only available on the server of the bad guy. And then you get a message saying, if you want your data or your systems back unencrypted, call me and I'll give you the, for a ransom, I'll give you access to your keys so that you decrypt the data and bring your systems back into practice. I'm not going to go through the details of the kill chain here, but you can go through it. This is actually work in collaboration with another company I advise, Versec. So approaches to protection, right? You could, in the first generation, you could do it pre-execution. You protect the firewalls, you look at traffic, you block bad actors, all that good stuff. That wasn't enough. People realized that most of the stuff was still getting through. So the generation 2 was post-execution. The attack happens, you discover it, you work on fixes, patches, whatever it is, and you get your system back and fixed, which of course leaves you exposed for a long while until the patching happens, which sometimes, by the way, might take 2 years to happen. The newest generation, what I call generation 3, is basically, can I do it at runtime, right? Can I detect that the code is not kind of on, it's gone off-piste. It's no longer on the road that of normal execution. And that you can do in microseconds and milliseconds, right? And that's when you can actually stop and say something bad is happening, put the brakes on and go fix it, and we can tell you what's bad. I mentioned it takes a while to fix. VSP stands for Versec security platform. But from the initial attack to initial compromise is typically hours, right? So half the time, within hours, you would know. Sometimes you wouldn't know for years, right? 2% of the cases, for years, you wouldn't know that you were compromised. From initial compromise, this is from here to discovery, right? To figure out, like, what the heck is it, right? If you notice, 31% is in the years, right? To understand what, what is really being compromised. And then finally, from discovery to containment, which is I fixed it. In addition to, this takes time, and now this is additional time to fix it, which takes about, on average, 53% is in the months, right? 22% are in the days. These are the really good guys, right? And the guys in the minority are within hours, right? 5% of the time you can fix it within hours if you're really smart and agile and all of that. So the timeline to containment for existing solutions is way longer. We think it's possible to do it in milliseconds if you're running, of course, in that time. So what does it take to run at runtime? Well, you need the ability to understand what's happening in compiled code, what's happening in interpreted code, and what's happening in process memory. And this is exactly how a company like Versec utilizes AI and analytics on top of the algorithms to very quickly kind of build that map and detect anytime you're off the legal roads on the map. It's very much like a GPS, and are you driving on the road or are you off road, right? And you can detect that without even knowing who the heck is attacking. The clear thing to keep in mind here, and I'm not going to go into the network layer, the host, all of that. At execution time, the whole idea is, are you on the right track or are you on the off track? And an attack occurs when the minute you go off track. And that could be the very start, for example, of a ransomware account. You would know it. You would know the minute the application has changed, you know something is wrong and you can block it. So that's the whole idea, is the platform actually monitors all these layers, but the one that acts in milliseconds is that kind of in memory, in real time, kind of watching the execution. So part of, how does that work that's relevant to us here is they build an application map that basically looks at everything. It looks at the package, the libraries, the scripts. All of this is done, of course, in automated ways. I'll give you an example of where they utilize AI and machine learning to do this. These are the meanings of the different steps here that go into the analysis that Vertex does of kind of all your apps that are running, and builds that map of how they should be running and when to detect when they're not. This is the coverage. This is one of the standard um, top 25 most dangerous threats, and this is their coverage. So they cover almost all of them extremely effectively, and in many cases with unbelievably with almost zero false alarms, which is in the world of cybersecurity, that's unheard of. But this happens because of the analytics, and the place where they use machine learning. I just wanted to talk about it quickly. Is at installation time, there's a lot of analysis that happens. Processes, maps get built basically of what's okay to access, what are okay libraries, is there anything compromised, and you deploy these sensors, and the workload utilizes machine learning to analyze the workloads and say, okay, here's what I expect to happen, here's what typically happens, all that good stuff, and that's where machine learning and big data get utilized, and that of course feeds back into the system, and that allows you to have that ability to kind of detect in milliseconds when something bad happens, right? And this helps protect the web systems, the memory, everything else on the system. And that's what it would take. Like the story of keeping data at rest safe is a big deal and requires a heck of a lot more vigilance. So with that, I have a few more minutes before I turn it over to questions. And I wanted to talk about the last part of the talk, which is what about the human and the AI, right? We've talked about machines. We talked about protecting data at rest. We talked about protecting data at use time with differential privacy and other technologies. I now want to talk a little, and we talked about the importance of data in digital. If you don't have it, you can't do AI, therefore you lose your senses. My last lesson was there is no autonomous AI, there is no general AI, it's about human-centered AI. So that leads me to talk about why we started the Institute for Exponential AI at Northeastern University. We have this high dependency on machine learning in making AI work. ML is highly dependent on data. That's a obvious, almost tautological fact. And AI applications are subject to bias, right? Because they get fed data. They have a limited view of the world. You feed them anything wrong, they conclude really bad stuff that could happen. So one question, since AI depends on data and therefore machine learning, what is the most expensive part of building a working AI application? I've asked this question of many people, and many people don't know because nobody talks about it. This is like the dirty little secret of machine learning. And what is the most critical dependency on keeping the AI application working? Right? So there's two things here. This is why we created the Institute. The most expensive part of building a working AI application is not just deploying machine learning, but actually getting to properly labeled training data, right? So do you have data that's reliably and accurately labeled? No one talks about it. This is where the billions get spent, by the way. But you don't find it in papers. You don't find people talking about how expensive it is to maintain that data at quality so that the learning algorithms are not learning junk. Because remember, garbage in, garbage out, right? So the Institute for Exponential AI is something we started at the beginning of 2021. The vision is to create the leading research institute in the world focused on the fusion of human and machine intelligence into working AI solutions. So our first thesis, which is almost counter to a lot of what happens in academia, is we need to be working on working AI solutions. By the way, this is, I believe, the secret of how China in the last 15 years, have managed to gain sometimes the lead, or at least catch up to the US, which had an 80-year lead on working on AI, right? So that maniacal focus on making stuff work in solutions uncovers most of the interesting problems that you need to solve to make the technology useful and work. So our main idea here is to augment or extend the best of machine algorithms with the best of what humans uniquely bring to bear, right? The ability to do common sense reasoning, the ability to do very quick decision making, what we call gut feel, which we don't know how to replicate in machines, is very useful. The right intervention at the right time. Oops, am I frozen? Okay. So what do we mean? What's the word experiential AI? Well, for us, it means AI with human-centric approach, i.e. human in the loop, applied to real-world problems, yielding pragmatic working solutions, right? That's our term for experiential AI. What's missing in data science and AI in academia is kind of exactly that working, the engineering of working solutions, right? That typically leads to finding the most relevant and interesting, in my opinion, research problems, right? In the word of Dave Rue, I was talking to him yesterday, and he put it much more eloquently than I did. He basically said the application shop floor is rife with Nobel Prize type problems, right? It's like embedded in those, making those applications work are some of the most interesting problems that once you crack them, they'll have amazing applicability. And typically, academia doesn't look at those. And of course, businesses don't have the time and energy to look into it, with exceptions, right? The exceptions, I can count them on the fingers of probably two hands. The second part is kind of leveraging, having this factory, this AI solutions factory, leveraging that activity of solving problems to kind of create courses and learning experiences that actually provide what is equivalent effectively to a residency program in medical school, right? An ability to actually work on real problems, supervised mode, where somebody explains to you what the heck is happening, but seeing the reality in all its ugliness, like what happens when data is not there, what happens when data is missing, when data is wrong, when the algorithms go haywire, right? Which is most of where kind of data science goes awry and you lose it. So for us, our approach for this data science and AI solutions factory is to kind of, we have staff who are professional data scientists and data engineers. We work on problems with our partners, companies, organizations, government, and we augment our professionals with faculty and research scientists who look at the deeper problems and help them out. And we use that to create the apprenticeship intensive residency program in data science, which actually addresses one of the biggest weaknesses in the data science market today, which is a typical data scientist graduates from university. And I assure you, and I've hired many of them, the first 3 years are all about, I'm going to hack at this data set with this algorithm. That almost never works. Like, you'd have to be super lucky for that to work. Really, the reality is you need to understand what are the problems with the data, what are the sensitivities of this algorithm. Often these algorithms are really stupid, very naive, and if you don't model that fragility and that brittleness of the algorithms, you're never going to get anywhere with data science. So with that, I'll get to my concluding slide and turn it over to questions. The final thoughts I need you to keep in mind: is there a strategy for human intervention when you deploy these AI solutions? Of course, data is critical, and without data and digitization, you will go blind as a business. Do you have a unified view of your customer, of your products, of your whatever, that give you context of the interactions? Can you provide data-driven personalization offers or content? That's my ultimate kind of litmus test. How quickly can you do it? And is the data access democratized, secure, enabling analytics safely and privately, right? And can your data basically enable intelligence in your digital channels? Because without it, you're going to run into problems. So with that, I definitely want to turn over to any questions you might have. I think my camera is kind of dropping, so let me fix it.
Oh, you look great. Don't worry about that. Everything is fine on that. Wonderful presentation. Thank you so much for that. And I'm going to jump right in. Again, you guys have the opportunity here to ask one of the world's most experienced chief data officers um, some questions about his long career in this. And I'm going to start off with just a comment, Usama. I hope this is a compliment to you. It certainly seems to be one from my perspective. It is refreshing to hear no BS discussion on the wider treatment and patterns of change.
Thank you for that comment. I'll take that as a compliment. And I actually, it's a really great point because you know, most people end up focusing on kind of the successful stuff. They only show you what happens after, you know, a lot of hacking took place and a lot of fixing and tip. Reality is we need to approach this pragmatically as a business process, as a business as usual, because we now live in the digital age where you actually have, there's an imperative here to have access to that data because it's the only way you're going to understand what's happening with the business.
I certainly agree with you. I'm going to ask you if you have read Amy Webb's book, The Big Nine.
I have not. I have not yet read it.
We had Amy as a guest at this event a couple of years back as well. Her basic premise is very similar, I think, to what you're arguing, that many of the AI pieces are focused, could be improved in terms of their focus. But her premise was that if you don't work for Apple, Google, Facebook, you know, the FANG type thing, or three big Chinese companies, that nothing you're doing in AI can amount to anything because you don't have access to the significant volume that you need to have on that.
I'll make a comment to this. And in fact, I think I used some of these slides in last year's talk. I call it the big divide between the AI haves and the AI have-nots. In fact, I have normally, you know, my background would be the Grand Canyon. And on one side of the Grand Canyon, you have some of these companies that you mentioned. There are more than 9, but less than 20. So that includes the likes of Amazon, the likes of Google, the likes of you know, Uber, many of the companies who've been utilizing data. And here's the dynamic, right? And this is why I use the Grand Canyon and it's the Great Divide. Because what happens is most business, 99.99%, is kind of on this bank of the divide. The AI haves are on this other bank, and they have an advantage, which is, you know, if you're a retailer today and you're trying to go into business to compete with Amazon, good luck to you, right? Because why? Amazon has been at it for 20 years, right? And when they started, it was very modest AI efforts, right? Little data, little AI. That actually gives them the experiential part, which is how do I make it work, right? And how do I make it work requires more data, more details, more context. And you then add in that data, which begets more AI, which begets more data, which begets more AI. And now you have that critical mass, which is very, very hard for anybody else to cross. And this is what we're trying to do here, both actually with my company, Open Insights, and with the Institute for Experiential AI. How do we help bridge that divide and democratize the access to the data? And how do we do it economically and quickly? By the way, these companies, because they were the early users, you know, the kinds of budgets that Google spent on data, the kinds of budgets that Amazon spent on data, you don't need to spend 1/1000th of it today because we learned a lot. There's a lot available in open source. There's a lot available in know-how. You just need to kind of have the right partnerships and the right talent, which is why I'm super excited about what we're doing with the Northeastern University at the Institute for Experiential AI, because the name of the game is talent. Can you produce talent that really knows how to operate in the space, that really knows the little tricks, and then help democratize the access? And I think if people think hard about this, they can avoid a lot with technologies. And I used a couple. I used one from cybersecurity. I used one from differential privacy, leap year. But if you leverage all the pieces that are available in the ecosystem today, it is very possible to bridge that gap and cross over and be operating there and start that virtuous cycle. And it's a cycle, it's a process. You're not going to be an AI giant overnight, but just starting, just taking those first few steps makes a huge difference in giving you that big advantage over the competition. And it's a process that takes, you know, months and years, but starting it is critical, because I think in the end, the survivors are going to be on the AI have side. And the guys on the other side watching, which is the majority of the world today, may not survive that big gap, that big chasm.
There's another book out there called "This Is How I'm Told the World Ends" that addresses very similar topics. We're running short on time here, but I want to make sure we get as many of these questions as we can. So a common industry academic belief is that all algorithms are already there. They lack the data to practice on them. What's your reaction? It would seem that experiential learning assumes some algorithms are yet to be discovered.
In fact, here's the news flash. Our algorithms are super weak. Our progress algorithmically in AI and in machine learning, and I speak as a practitioner, and it hurts me to say it, like I would have never said this 20 years ago, has been dismal, right? Our ability to kind of build models from data, the best machine learning system I can think of to date, right? I mean, there's good examples out there, and there's companies who made amazing use of machine learning, Google being one of them, and many others. But one of the best examples is from the 1950s, the late 1950s. Samuel's checker player, which was done, way back when at IBM, utilizing computers that had tapes. That still stands to this day. Like the algorithms used there to help an algorithm learn how to play checkers better than humans and better than champions, where purely through machine learning, we're there, and everything here today is a variation on that theme. So our advances algorithmically have been extremely limited. We just have a lot more data. So the question now is, by leveraging data, we've seen a lot of progress. We can do amazing things, but most of the time we are regressing our way around the real AI problem. So most of the AI solutions out there have nothing to do with how human intelligence works. They give me no insight, right? They work well in the very, very narrow context that they were designed to work in, with that data when that data is complete, right? One of the rules in the 5 lessons is you have to have complete knowledge. The only way to have complete knowledge of a domain is if you narrow it completely. So in those very narrow contexts, you can have progress. Data can help you have that amazing progress. And you can have things that look like magic. I've had the privilege and honor to participate in many areas, working with scientists, working with business people, where they look at the solution and they say, this is magic, right? How does this box know what to do? But in reality, that box is typically really stupid, really dumb. A lot of energy went into making sure the data feeding into it was the right data, the right quality, at the right level of granularity, at the right level of detail, with the right updates. And that story is very complex. Making sure that your data ecosystem is healthy enough, that it's taking in all this information, keeping it fresh enough to create the relevant and right predictions is very difficult. And to me, that's why I spent most of my time trying to democratize this, that you don't have to be a Google to have data under control, growing business. You can actually get it done by leveraging what's out there correctly, and leveraging the know-how and working with the right partners to help you get there very quickly. So that's what gets me excited, is I believe it is democratizable. I believe data can get us a long way, but algorithmically, we are not even at the beginning. We are at the very beginning of the beginning. And there's a lot to be done, and that's okay. From scientifically, these things take many decades to develop into kind of real sciences, but we're getting there slowly, a lot slower than the world thinks, and which is why we keep going through these winters. Right? Everybody sees the magic box working and says, "Oh, you're there," and unfortunately, people get tempted and say, "Hey, I'm there. I touched the sky," and then the next thing that happens is people realize, well, this is nothing more than just regression. You use data to kind of avoid the problem. So,
ouchie, ouch. Well, we have run out of time. I'm sorry we didn't get to a couple of other questions. I did have somebody specifically that wanted to ask you about your experience in data privacy. Would it be okay if I connected that individual with you as well?
Yeah, or if you send me the questions, I will post the answers on LinkedIn. We'll have several postings answering any questions you might have that people send in, or even post in response to our LinkedIn. Happy to kind of answer those questions over the next couple of weeks. So we will address every question that comes up.
That would be great. Usama, thank you so much for taking time to share with us. And we look forward next year to coming back and telling us how you're progressing with the Institute, because I do think it is an important development in the academic world that you're heading.
I'm speaking to you today from Portland. I'll be in Boston next week, and always have lots of great stuff happening at the Institute.
Absolutely.
Both at the RU Institute and the Institute for Exponential AI.
Usama Fayyad, thank you so much for joining us today. It's just been a great session.
Thank you.